It's my great pleasure to introduce Professor Alasdair McDonald. He conducted his PhD here from 2004 to 2008 on this long topic called structural analysis of low-speed, high-torque electrical generators for direct drive renewable energy converters. I wonder how many pages.
Too many.
Yes, after doing some postdoctoral research, he actually started a university spin-out with colleagues to develop a novel permanent magnet generator technology. But then he probably got bored and decided to return to academia in 2012, first as a lecturer in wind turbine technology, not here, at University of Strathclyde. I think I met some of your former colleagues. They want you back. And I said no. He came back to Edinburgh in 2021, taking up the chair in renewable energy technology in the Institute for Energy Systems, IES, where since 2023, he also has been the head of this institute. As a new head of school, I actually, unfortunately, haven't got a chance to really interact with you very much. But the limited time I did get to talk to him, I found actually Alasdair to be a very kind and very thoughtful person for other people. Thank you. I really appreciate that. Because tonight is the night before Halloween, I thought I would mention that Alasdair actually is scared of many things. You probably know. We'll find out. But wind turbines is not the thing that scares him. So let's give a warm welcome to Alasdair.
Franco, thank you very much for that introduction. And friends and family and colleagues, thank you very much for coming tonight. Those of you that haven't been here to the University of Edinburgh before, very welcome. And colleagues that I know really well, you're also very, very welcome here today. It's quite difficult to think about how you give a talk, a lecture, to Cora, my daughter here, 10 years old, and also people that have been studying research in engineering for 45 years. How do you do the balance of that as a talk? And I will try and do all of those different things. Some of you will know a lot of this material already, and hopefully there'll be a little bit of something in here, this talk, that will be of interest to you. Some of you have never thought about this before, and hopefully there's bits which are accessible. Hopefully there's a few fun bits in here. Hopefully there's a little bit for everything here. Normally when I do a talk to students, they have to stay here in this room, so that you don't have to do that. And if I do a bad lecture, I've always got next week to make it better, and I don't have that as an opportunity. If I make a mistake in front of my family, they're very good at forgiving me and letting me move on. And if I do this in front of colleagues, there's normally a way of getting it right. It's quite stressful to have both friends, family, colleagues, and students all in the same place. But it's great to have you. If I can, I'd like you to take you back in time to begin with. Back a few years ago, back to when? The 1880s, the 1890s. Step back in time. And here are some pictures back in the late 19th century. Top left picture is, you might recognize as Princes Street, the end of Princes Street. About that time, we were just building the 4th rail bridge that was being built. Bottom left is a picture of the first power station here in Edinburgh, used for lighting down on Dewar Street. Bottom right-hand corner, just released. It's Halloween now, so I was thinking about Halloween. Dr. Jekyll and Mr. Hyde, written by Robert Louis Stevenson. And the one thing that we proud engineers here at Edinburgh know is that Robert Louis Stevenson studied engineering here And if you go to his Wikipedia page and look it up, the one thing that you read is he hated engineering. And apparently he did everything he could do to avoid going to lectures. Amazing. He was such a forerunner for many of other students. I joke. But anyway, at that time was a great change in society, technology, the way that people were understanding the world. And there were lots of mechanical engineering, structural engineering, chemical and electrical engineering challenges. Like today, a great time of technological change. And around about that time, here at the University of Edinburgh, wasn't studying in a school of engineering, he was studying natural sciences or natural philosophy, was this gentleman here, James Blyth. And in '61, he graduated from here with his Bachelor's of Art, and later on he came back to the university to study a master's. And he was a real inventor, a real interested in technology. And he started to play with electrical engineering, what we would recognize as electrical power engineering, batteries, generation of electrical power. He subsequently went on to become a professor at what's called Anderson's College, the precursor of the University of Strathclyde. And it was at his holiday home up on the east coast of Scotland in a place called Marykirk, where he was the first person in the world to design, build, and test a wind turbine. Now, that was what Marykirk looked like in those days, okay? And here are some of the pictures, quite grainy pictures of some of the first turbines that he built. Hopefully you can see that there. Okay, there's one of his turbines just about there. Okay, turning around and looking at from the house, you could see that there. A real inventor. Imagine going down to your garden shed and building this kind of thing. And it was really successful. He said, when a good breeze was blowing, I stored as much in a day, half a day, as could give me light for 4 evenings. He had batteries. He was able to store this electrical energy. And it had so much, this abundance of free energy that he thought, well, I'm a good person. I want to make the world a better place. I'll offer it to the people of Marykirk. And he talked to the village elders and he said, would you like me to install some of these new electrical lights and use our wind turbine to power that? And they said, no. They said, it's the work of the devil. We don't want it. So that's the starting point for today's talk, about the things that scare us about wind energy, the monster turbines that make shivers run down our spines, and some of the scary engineering science of wind energy. So, let's get into that. You may notice a few Halloween bits in this talk. So if you want to keep a count of all the different scary things that come up, we'll see how many we have at the end. So, today, why are we interested in wind energy? Let's have a little look at that. And there are a few different reasons why there's so much interest in the outside world about wind energy today. And some of these will be familiar to us, but let's quickly fly through them. One of the things that we hear a lot about at the moment is net zero, moving towards a society where we have reduced our carbon emissions. And here, this is some of the work that informs many of the different international treaties that we sign up to. And this is what we need to do as a world if today we start seriously trying to reduce our greenhouse gas emissions. And we have to rapidly reduce the amount of emissions in every country. Whenever I look at this graph, I'm reminded of a saying that my Irish in-laws always tell me, is that this isn't the best place to start from. If we'd started a few years ago, our transition would be much easier. But moving towards an energy system which doesn't release as much greenhouse gases. As we cascade from that international motivation down to the UK motivation and what we want to do, this is from the Committee of Climate Change. in every sector, in every part of our life, in every part of our society, we need to reduce the amount of greenhouse gas emissions. And that means moving every sector to one which is using renewable energy to provide that energy. Even if that wasn't happening here in the UK, we have other motivations. We have motivations in that the forms of energy that have been driving our society for decades or centuries are running out. So the costs of extracting oil and gas means that the amount that we have available is reducing. So just from being able to self-sufficiency and energy security requires us to move to something which doesn't rely on imports. The other reason why wind energy here in the UK is because it's, well, really windy. And that we instinctively know, but here we can prove it to you. These are the darker colors here mean it's really windy. And in the UK, Ireland, anything that's close to the Atlantic, fantastic wind energy resources. We are blessed by how good our wind energy resource is. And that means that the cost of generating electrical power from wind is much lower than in many other countries. And different people look at the different costs and the through-life costs of different technologies. This is some data that comes from the UK government. And it tells us that today, wind energy can deliver some of the lowest lifetime costs of energy. So it's good stuff. It's good stuff to go for. And if we look at where we get our energy from today and where we use it, so the left-hand side is how much energy we get from different sources, and not just electrical energy, but all the types of energy that we might use for heating, for transportation. We have these diagrams here from the national grid. And what we can see is roughly at the moment, or last year, we get about a third of our total energy from natural gas, about a third from oil, and about a third from other things, including wind. And in there, if you squint a little bit, you'll see a few little wind turbines. And there's a good amount in terms of electrical energy, but now total amount of energy is relatively small. So that's where we are today. The plans, the forecasts, the scenarios, and the pathways to getting towards net zero look a little bit like this. In 2050, according to most of these different pathways, 40% of our energy, total energy, the energy that we use for heating, the energy that we use for transportation, is going to come from wind energy. And that means we need to scale up by about a factor of 5 how much energy we get from the wind. These are really big numbers. How are we doing in terms of getting there? Well, we've got good news. In places like here in Scotland today, we look at the last few years and how much wind energy we've been installing. We're making good progress. Green here is onshore wind here in Scotland. Blue is offshore wind. That's taking off and starting to increase quite significantly, and will continue to do over the next few years. Good news. If we look at it from the UK perspective, every year, seems every month, we seem to be smashing records. The most in a year. Wind energy starting to dominate our electrical power system. Records coming down. Really good news. But I'm sure many of you also have a look at some of those newspaper headlines or things that pop up in social media. Headlines that say things like, wind turbines will blight your holiday hotspots. They will devastate your area. They will take you where you live, the landscape, and rob it of its soul. And just angry. And it appears to me that wind turbines really scare us, or some of us, or we worry about them. So do they scare us? Why do they worry us? So if you have a device, I'm going to poll you, see how you are. Now, you can either use that QR code, or you can go to wooclap.com and add in that event code, and you will be asked 3 different questions. And those questions, the first one will be about your support for onshore wind energy, your support for offshore wind energy, and it will give you a scenario that someone is going to build a wind farm near you, maybe at Blackford Hill, if you live near here. Think about it as being Blackford Hill. And how much do you think about that? What do you feel about that? Is it working?
Yeah.
It's working, okay. Okay. We'll use you as a little sample, and then what I will do is show the results as they come in, and we'll compare you to the general public. And I'll see if I can do that here. Okay. Right. If I do this, Alt Tab. Okay. Okay, give you a few. So I'll show you the first one here. Okay. So this is an onshore wind farm. So one person is very unhappy so far. 9 people are unhappy. That's probably just my family trolling me. That's okay. That's fine. That's all right. Some very happy. That's good. I like to make people happy. Some are just happy. That's good. A few of us don't know enough. That's good. That I enjoy that level of skepticism. I need to know some more information first. We should applaud that. And some people, quite rightly, are in the middle of Edinburgh and don't think it's possible in their area. Okay. That's onshore wind. Let's move on to the next one. Offshore wind. So just from there, we've got 32. We're pretty, probably 70% happy or very happy. Okay. Let's move on from there. Okay. Move on from this. Right. Okay. Now we've got one which is offshore wind. So hopefully we're adding into this. Okay. Let's see how this goes. Is it going to be different? Okay, so it's a little bit different now. This is offshore. Okay. Anything? It's the same types of wind turbines, same technology. It appears that we seem to be a lot happier about offshore wind. I mean, apart from lighthouse keepers, not many people live directly next to offshore wind. Okay, let me move back to that. We'll maybe show these up at the end, and let's have a look at this. Okay, so how are you compared to the general public? Let's see what the general public has to say about it. Okay, back to there. Okay. So, if we looked at the general public, there's a slight discrepancy between offshore wind and onshore wind. Generally, people are quite happy with offshore wind because it's somewhere further away from me. And if we slightly bring it, still in the abstract and the generic, bring it slightly closer, onshore wind, but not where I live, but onshore wind, it's still very happy. And that's what happens generally if we keep on going back to the UK public and asking the question again and again. These numbers change a little bit from quarter to quarter, year to year, but generally speaking, people are very positive in the abstract. Okay. So it seems like we're quite aligned with that. If we talk to people about specific places that they can think of that are close to them, the numbers tend to change. So I always like to show this as a picture. It's some sort of way of making the wind turbines look really big, like they're leaning over and frightening the people that live there. And that suddenly changes people's perspectives. And when we look at that, when we say it's near to where you're going to live, are you happy or unhappy, the numbers change it quite a bit. Still generally positive, quite a few, I'm not sure about it, quite a bit, don't know, I want more information. But as it gets closer to us, we start to have maybe second thoughts about it. We're slightly less happy about that as an idea. And why is that? Are you hypocrites? Well, we probably are. But it's a slightly different question. It's a generic question. It's an abstract question to a real question. And one thing that I've kind of noticed throughout life is that generally people don't like change. And we particularly don't like change if we feel like that change is something that we're not in charge of, that is happening to us, so we don't have control. If we don't really understand or believe we need to have that change. Sometimes if we think that change has a risk. And sometimes if we think that we might lose something with that change. And the other thing that sometimes happens for those of us that work in renewable energy, that we notice that sometimes there's information which isn't quite correct, and it sometimes feels like people are influencing others to try and reject that change, and some of those headlines are to do with that. If we go and ask the public why you're not interested in it, why you don't want wind energy, and dive into the details, they talk about things like noise, view, things like that. And we can partition these into different aspects. And actually the planning system actually looks at a lot of these different aspects and tries to make sure that wind turbines and wind farms, when they're built, make sure that these aren't a problem. But these could be, you could think about these as those where it's being done to us, people are making money, we're not going to benefit from it. That's control is being done to, we're losing control, it's being done to us. Sometimes it's because people don't understand the motivation or don't believe in the motivation. Sometimes it's risk, I want safety. And sometimes it's a feeling that we might lose something. And that might be, we might be losing our visual amenity. Now, I've got pictures here. They're all in black and white because I put the coal-fired ones that I could only get black and white photos, and I thought you would think that I was trying to make the wind turbines look nice and colourful, and I couldn't do that. I had to make them all black and white. This is Drakelow Power Station. If I wasn't, there's a little dirty secret from me, as long as we can cut this later on. I actually like coal-fired power stations. I think they're really beautiful, but most people don't. Now, Scott, you and I grew up near Drakelow Power Station. That's where our next-door neighbour used to work at that coal-fired power station. So in a parallel universe, I think I would have been working in a coal-fired power station. Very happy. So I happen to think that it looks quite nice, but many people don't. Now, in the past, there were some people that didn't mind coal-fired power stations, and that's where we lived. And the rest of you all just enjoyed the electrical power. You're welcome. Now, today, it's not like that. We can't have big, concentrated power stations. We need renewable energy. And it tends to be quite dispersed. Now, that, unfortunately, means that we need to put more devices out there. And that does mean that we need to democratize and spread out the change in visual amenity. But that is a major concern for people. And it's a concern when there's a change. Now, the interesting thing, this is Whiteley Wind Farm, which is where we often take our students to look at. They have a wonderful time. And there are 3 parts, I think, of Whiteley Wind Farm. They built it in 3 stages. The first stage was really difficult to get through planning. The second stage was really straightforward. And the third one, no problem at all. The reason being, if you've already got a wind farm, it doesn't matter if it's slightly bigger. Okay? So the change, when people are, suddenly the change isn't so big. And we see that again and again in different parts of energy infrastructure. So we worry about that. Second thing, wildlife, plant life, birds. Put your hand up if you live in a place with glass. Cat killers, the lot of you. They're bird killers. Okay. Yeah, that was the wrong thing. Who has a car? You're even worse. Who has a cat? You're the worst of them. And who owns a wind turbine? I own a little bit of a wind turbine, but it's about that much. So I'm afraid I'm the best of us all, really, quite frankly, but you're terrible. So, no, joking aside, the things that we do when we're developing and planning a wind farm include really quite significant surveying of bird life to try and make sure that the impact on bird life is minimized. Yet at the same time, we don't do anything like that when we build a building. And so we actually set a higher threshold of evidence for wind farms. Okay, house prices, that's something that people really care about. And this was some work done through the Climate Exchange, which has run out of the city centre here. They were interested in how does putting a wind farm near a property, how does it affect property prices relative to a control somewhere else that doesn't have any wind farm? And the conclusion that they came up to was that it doesn't really make that much difference at all, which is, I found, quite surprising. The other thing that people worry about in wind energy is how expensive it is. And actually, the interesting thing about how our energy system works today, at any given moment in time, we will find all the different types of generators. We're going from the cheapest on the left-hand side to the most expensive on the right-hand side. And when we work out how much electrical power we need, we take the price of the most expensive thing, and that's what all the generators get. And today, on most days in the UK, the most expensive thing is gas. The only thing that we could do really to bring that electricity power, that electricity cost down, is to try and increase the amount of renewable energy. And many people worry about the price of electricity. You read it in the paper. Is this because of our net zeros? Is this the reason why our electricity price? No, the reason is it's so expensive today to make electrical power from gas. Indeed, if we look at what happened during the problems in Ukraine and the subsequent cost of gas, in some of the ways that we produce electrical power and sell it today using something called a contract for difference, when the price went really high, and some of these have what we call a strike price or a limit price, and when the price of electricity goes above that, they start paying money back to us. And that's what happened during that moment when the cost of electricity went really high. The wind farms with contracts for difference started to pay us money back. They were starting to reduce the amount of cost. So actually, today, relative to some of the other ways of generating, electrical power from wind is relatively cheap compared to some of the competing technologies. Okay, I'm going to stop for a little drink of water. So, I may spend the rest of the night trying to persuade you that wind turbines aren't very scary. But they're definitely magical in some way, and it feels like magic in Halloween is an important thing to do. And the week before last, we were in our ID core course, we were trying to work out how wind turbines work. And there was a little bit of magic there, wasn't there? I think we finally got the spell. So I'm going to try and do a shortened version of that to find out the magical engineering of wind turbines. So, wind turbines, of course, are a little bit like windmills. The first windmills that ever came around were from Persia, so modern-day Iran. And they looked a little bit like these Panamoni systems here. They have got a wall built, they're a vertical axis, and essentially the wind blows through between the gap in the wall, it hits one side of the rotor, and it pushes that rotor around, uses drag on it, and that thing rotates. And underneath, below those Panamonis, is a mill. And that's how those first windmills came about. And James Blyth, his system looked very similar to that. Again, it's a vertical axis turbine here. There was no wall to protect one side of the rotor, but rather he had these sails shaped in a particular way, and one side of those sails has a certain drag coefficient, the other side of the sail has a different drag coefficient. That differential force forces the thing to go round. Okay, so that's how he started. But if we look at modern wind turbines, they're what we call horizontal axis. They have 3 blades. Those 3 blades are connected together to something called a rotor, and they turn. And we've got a little one down here that we'll look at in a bit. Generally, what happens is that rotor is positioned in front of a tower to always point towards where the wind is. And the wind direction changes quite frequently, and we measure that, and the turbine yaws. It moves the rotor to face into that direction. As the rotor moves around in space, it actually sees wind from 2 different directions. One, of course, is the wind moving towards it, but also if you were to hold on to this turbine blade as it rotated through space, it would appear as if the air was moving towards you. Okay, so that blade is rotating like that, and if you held on to that blade, it would look like the world was moving towards you, the air was moving towards you. And so that in itself looks a little bit like the wind. And these wind turbine blades move through space so quickly, it's often about, for an offshore wind turbine, about 100 meters per second. Onshore, maybe 70 meters per second. It's about 8 to 10 times faster than the actual wind is moving towards the wind turbine. I looked this up, in terms of witches and wizards. A tip is at 100 meters per second, that's about 223 miles per hour. Harry Potter, now I had to look this up because first of all he started with the Nimbus something, that was quite good, but then he got upgraded to the Firebolt, which is 150 miles per hour. And there's something called a Firebolt Supreme, but it didn't tell me how fast that was. So anyway, it's faster than Harry Potter is moving through space. Okay. So if Harry Potter wanted to hold on to the tip of the blade, he would be having the ride of his life on the end of this. So if you were a witch or a wizard and you're on that at the tip of the blade, it would appear as if the wind was coming slightly from you from the wind itself, but also you're moving through space and it's moving towards you. And the combination of that does that. And you would feel that a lift, okay, that's a big force that's following the green bit, and a little bit of force which is starting to slow you down a bit, called the drag. And you can combine those 2 together, you get a total force, and you can do that at every bit of the blade and add them together. And when you add them together, you get 2 components on this rotor. You get one which is tending to bend or force the blade back towards the wind turbine, and another component which is tending to push the blades forward to make it rotate. Okay, one of those forces we call thrust, and that's something that structural engineers, designers of these wind turbines, gives them headaches. And another component is going to produce something called torque. Torque is when you've got a jam jar, you're trying to open the lid, you apply a force, at a distance from an axis, and you twist it and it rotates. And it's that torque which we're going to use to produce electrical power. So we have this mechanical power on a shaft, and inside the nacelle is something like this, or it might look like this. So here's an electrical generator, and this is the thing that's going to accept that mechanical power, and it's going to produce electrical power. Look at that generator in there. It's really big. There are some people down in the bottom. These are not little mini people. These are just normal people of a regular size. And I looked up. If they were zombies, a zombie is on average 1.65 meters high. So you could see how many zombies across that would be. I reckon 6 to 7 zombies in diameter. Okay. This is actually the bit of research that myself and other colleagues here at Edinburgh, when we look at electrical generators, we love this stuff. I'm not going to talk about it, though. But this is the stuff that's really interesting. And when we work in the lab and we do stuff, and Marcus, I can see Marcus here, this is some of the work that we've done together over the years, designing different types of cool electrical generators that are lightweight, that are amazing, that are highly efficient, that are reliable, that do all sorts of things. That's what we do. That's what I do as my day job. Okay. Now, when we're generating electrical power, of course, we're going to turn that into volts and currents. But we also appear to produce a torque in the opposite direction to that from the wind turbine rotor. And the amount of torque, this twisting force that we can produce, depends on the current that flows in our generator. And our colleagues, I can see Paul at the back, our colleagues who work in power electronics, they're the people that are going to control how much current is flowing in our generator. They therefore control how much torque the generator produces. And the balance of the mechanical torque and the electrical torque tells us, is this rotor going to accelerate, spin faster, stay the same rotational speed, or decelerate? So they are the people that control how this turbine is going to work. When the wind gets really windy and we worry about this thrust force and we want to maintain a certain amount of power, we can also change the orientation of the blades. We can pitch them. And we have different mechanisms for doing that. And most modern wind turbines are able to do that pitch regulation to limit the thrust force on the system. Okay, I think it's time that we show this in real life. I was wondering, could I have a volunteer, someone who's got long hair? Cora, I'm looking at you. Can you come out here? Okay. Right. Come over here, you stand here. And what I'm going to do is, just before we play with the turbine, which is here, I've got a fan. This is my mock wind. And we've got a few different settings. And we're going to find out how windy it is. Come a bit closer, if that's all right. I'm going to turn it on. This is why you needed the hair, because this is... I've got an anemometer. This is measuring air speed. It's not working at the moment, so we're going to use hair speed instead. Right, okay, come a bit closer. So this is probably about 4 meters per second as a wind speed. This is a wind turbine. We're just about starting to go now. And if I go up to here, I think I measured it before at 6 meters per second. Okay, for a wind turbine, this is still just really getting going. It's when we get up to about 12 meters per second that we're okay. Okay, I'll turn it down for a second. Okay, right, okay. There were 3 things that you can take a little step back if you want. There were 3 things that I wanted to show you with this turbine. Wonderful little turbine here. First of all, if we said that we wanted to turn the turbine into the wind. The reason for doing that is as it moves away from the direction of the wind, the amount of power that we produce will diminish. So, you gonna hold on to this? Okay. Okay. So at the moment it's heading into the wind. Have the wind direction changed? If you rotate it around that way. And if the turbine wasn't able to change direction, we would rapidly lose some of that power. So that's the reason why we need to yaw the turbine. Okay. Okay. The next thing we can do, I'll give that to you. At the back, I've just started to generate some electrical power now. And as that current is starting to flow, we have a counter torque. And what we can see is that the turbine has slowed down. If I turn it off, it should accelerate. And if I push that in again, it will slow down a bit. Okay, stop that for a second. The other thing that we need to know is that as the wind speed increases, the amount of power that we're going to produce is going to increase. And if this is the wind speed, the velocity, the amount of power that we're going to produce depends upon the Q. So the velocity multiplied by the velocity multiplied by the velocity. So if it's going to work, it's going to start to accelerate. Okay. I think it is. Very good. I'll stop that for a second. The other thing that we can do with this turbine is we can pitch the blades. So I'm going to turn it around like that. Hopefully, I've done it the right way. Ready to go again? You sure?
It's very cold.
It's very cold. Yeah, right, okay. Okay, we've now pitched the blades. This is what we do at very high wind speeds. And in this case, what we can see is the turbine is rotating more slowly. And that's what we do in real wind turbines. Now, before Cora freezes to death, I'm going to stop. But if we could give Cora a warm round of applause. Okay. Okay, that will be available to play around with later on. Where did I put my little clicker? Put my clicker down over here. Okay, so there's our turbine. Right, time to hurry up. Okay, fire through here. When it comes to designing these turbine blades and the forces that are acting upon them, we have expertise here at the University of Edinburgh that are doing all sorts of exciting things, partly in wind turbines, but also in tidal turbines. And I was with colleagues today over at Fastblade in Rosyth, where they're testing composite turbine blades, state-of-the-art facility. And we have colleagues here in the Institute of Materials and Processes are looking at how you recycle those blades when they come to the end of their lifetime. Really exciting, important aspects of turbine design. Okay. When we look at wind turbines, the amount of power that we produce, I said, depended on the velocity, the wind speed. It also depends on how big the turbine is. And the turbine we described as how big it is basically the area of this big circle here on my front here. Okay? So the bigger that rotor is, as I move from one turbine to another turbine to another turbine, tells us how big, how much power we can produce, and therefore at what wind speed we can produce it. And as we see today, turbines are getting bigger and bigger. I'll move on here. Now, the other thing that determines how good a wind turbine is, how much power we're going to produce, is how good our generator is, how good our electrical system is, but also how good our rotor is. And even Blyth, when he was playing around with wind turbines in his garden, was looking at vertical axis turbines and horizontal axis turbines, looking for turbines that will produce or extract more and more power from the wind. And people throughout the history of wind turbine design have played around with a number of turbine blades, from the weird one-blade turbines to two-blade turbines to the more recognizable three blades, even to ones which are used for wind pumping with many, many blades today. These all exist and have been played with. And one of the reasons why they do that is to look at how much power can be extracted from the wind. That's what is on the y-axis here. And the more that we can do that, the better. And the modern three-bladed wind turbines tend to give very good power extraction, high power coefficient, and also do it at a high rotational speed. So the blade is moving relatively fast relative to the wind, and that means a high rotational speed, and that makes the job of turning this into electrical power quite a bit easy. And this tells us, as we go to one of those curves, we need to be able to control the rotational speed of the turbine. Okay, so that's how turbines work. I've got a few minutes left. You now understand the magic of wind turbines. I've now made sure that you're not going to be scared as you walk out the door, and you're not going to be attacked by a wind turbine. But I'd like to let you into a secret. Actually, there are some really scary things about wind energy. What are the really monstrous things? The really scary thing is how many challenges there are out there today. So, here are some massive, monstrous wind turbines. This is a Vestas 15 megawatt turbine, state of the art. If you wanted to buy a wind turbine, you had many millions of money in your pocket, you might go out and buy one of these. A 15 megawatt wind turbine in terms of power, for a year, that would probably give all the energy for about 10,000 zombies. It's got a big nacelle, that's the bit that sits on the top of the tower, 630 tons. I think that's about 2.5 million pumpkins, SI pumpkins, that is. That's a joke for engineers and scientists. Each blade is about 70 zombies long, SI zombies, and about 100 zombies high, not stood on top of each other, but if you laid out the tower, like on the head. So pretty big, pretty monstrous. If we compare the bit that sits on top of the tower, where there's a standard zombie there in both pictures, you can see that relative to James Blyth and his turbine. And that nacelle is actually on top of a tower, which is that bit up there. So absolutely huge systems today. Massive pieces of engineering. And these are pieces of engineering which are far bigger than the people that work in designing aircraft. Bigger even than some of the big structures that we look at today. Massive engineering challenges. The cycles of loads that they go through is awe-inspiring. I thought that this slide was going to be okay until last week, when there was a new turbine, a couple of new turbines, a 26 megawatt one in China by a company called Dongfang. And I think even today there's been another one that's even bigger than that. These turbines are getting really big. The reason why they're getting really big is that when we put these offshore, we want to reduce the number of turbines. And it reduces the number of things that we need to put into the sea, the connections between them, and the fewer that we can have, the better. And unfortunately, that means that they get bigger, and that makes the challenges of designing them even more challenging. The other thing that scares me about wind energy is that we're going to have to connect it to our creaking power system. So today, round numbers, if it was a really good day, we were producing all the generation that we wanted here, or could do in Scotland, it would be about 18 gigawatts. That's a big number. And our maximum demand might be about 4 or 5 gigawatts. The amount that we can export, send electrically to the rest of the UK is about 6 gigawatts. Why? Because we haven't spent very much on our grid in the last 2 decades, despite us knowing that this was going to happen. That's not the bad bit. The bad bit is we're going to put in much more generation. The demand is going to go up a little bit, but not much, so we need a bigger grid. The response to this is all of these green and blue lines here on the map. We are essentially going to build an entire new grid offshore just to get this electrical power from here in Scotland to the rest of the UK. It is one of the biggest infrastructure projects that we have ever seen here in the UK. It's awe-inspiring, it's scary, and we should have started it already. Okay, and that's going to need lots of people doing lots of things with lots of skills and lots of change to our electrical system. And that's where our colleagues who are interested in, our colleagues in power electronics that are working on HVDC and amazing bits of power electronics and power converters that are sending large amounts of power at very high voltage efficiently and as cheaply as possible. And again, that's pictures taken from our lab. A few other things that are happening that are exciting to know about. Picture from last week, looking at our wind. Blue colors here are low wind speed, low power. The kind of greenier, reddier, oranger are high wind speeds and high power. Two different points in time, and where the turbines are, where future ScotWind wind farms are going to go. The further away we put our wind farms away from each other, the less correlated they are with each other. It means that they will see the peaks and the troughs of wind energy at different points in time if we push them further away from each other. So one of the things that people are now thinking about is how do we push those wind farms further away from shore? And as we push them further away from shore, that means we get into deeper water. And as we go into deeper water, we need to change our turbine systems. And that's where some of the challenges, some of the really interesting things that are happening in wind energy, moving towards floating turbines. Here we have different types of systems that have been tested around Europe. Two of these types of systems have been tested here in the UK. And there we can see the one that's just off the coast of Kincardine, not far away from James Blyth used to live, actually. And that's one of the 5 floating turbines that are being tested and run today. One of the exciting things to be working at here at the University of Edinburgh is that we have a fantastic facility just up the road here, Flowwave. And in there, they are testing small-scale, different turbine foundation systems. And we're in there with Tom today having a look at that. And it's amazing some of the work that colleagues are doing in this area. Really lucky to be here at the University of Edinburgh working on some of those systems. If you get a chance to go and see Flowwave, see the amazing wave and current systems that are on there, and the ability to apply loads onto turbine systems and understand how they can operate in different conditions, I would urge you to do that. Okay, final 2 slides before we wrap up. We're reflecting a little bit upon what our role as a university is, or universities in general. How can we help here? Well, over the next few years, there are all these different projects that are going to be delivered here in Scotland. And there's hopefully lots of companies and organizations and supply chain that's going to help deliver these projects. And I think that there's expertise across all of the Scottish universities that can be really key in helping lots of different companies to help deliver those projects, whether it's the developers themselves, or it's the people that are supplying the different pieces of equipment, or the specialist consultants that are having to do things that no one's ever done before. So the requirement for innovation, that's really exciting. The other thing, of course, is the number of people this is going to require. And that's the other role that we as a university and as universities across Scotland can help with, is helping to train the generations of different engineers and other types of wind wind farm and wind turbine specialists that are required in this industry. So I think that's maybe the one thing that I would like to leave you with. That's almost the end of the talk. And if you don't mind, I'll use an epilogue. Going back to Marykirk. And over the summer, I went to Marykirk, and they had, hasn't changed a great deal. I don't know where the horse has gone. There's a, whatever that is, a Passat or something like that, or a Ford Focus. And they had Scottish Renewables were doing a really interesting thing. They were celebrating the life of James Blyth, and they had a blue plaque. And they had this wonderful event, and they had 2 great-grandchildren of James Blyth. And they told this family stories about James Blyth. And they held this in Marykirk Village Hall. Okay, that's where it was. Kind of place that you go to, and the scouts will be in one night, and then there'll be a dog show the next day, and there'll be a birthday party the next day, and then there's a Scottish Renewables event the next day. And in there, they pointed up and they said, you see those lights up there? Those are new LED high-efficiency lighting. And they were really pleased. It was great. And I said, yeah, how did, where did you get the money for that? And they said, well, there's a local wind farm that has a community benefit fund, and they gave us the grant for it. So all this time later, eventually, it took, a century and a bit. But finally, James Blyth can be happy knowing that his invention is paying for the lights of Marykirk. And with that, I'd like to say thank you very much.
Thank you very much, Alasdair. It's a very interesting and informative presentation, and I'm sure that everybody like me is a bit less scared of wind turbines than we were before. It falls to me to ask you all once again to put your hands together and to thank Alasdair for a very interesting and informative presentation. And I now have to disappoint some of you in the audience by telling you that it's traditional at these lectures that we don't have questions at the end. So the colleagues from Strathclyde who were going to ask the question of when is Alasdair going back to Strathclyde are not going to get to ask their question. However, it is my duty to inform you that if you get leave by the exit at the top of the lecture theatre and go upstairs or go out the front and upstairs, there is a reception waiting up there, and there we can help ask some informal questions and quiz Alasdair's family to find out if they really understood what their dad was talking about. So I'd like you to join Alasdair in celebrating his fantastic talk. Thank you.